Hello students, today we are going to study the synchronous counters. Okay, so what is a synchronous counter? Let us try to understand this. Here we have taken an example of a synchronous counter which consists of two flip-flops. So this is the first flip-flop, which is a JK flip-flop, and the second flip-flop is also a JK flip-flop. We can observe that the clock signal for the first and the second flip-flop are shorted to each other and are provided a common clock. So this is acting as a synchronous counter because the clock signal is shorted for all the flip-flops we are considering in the counter. Now, let us understand some more things here. There is a term mod 4. What does this mod 4 synchronous counter mean? So mod for a counter is basically the modulus value, and it gives the number of states which are possible for a particular counter. Let us try to understand this better. Like we have two flip-flops, so there are two outputs here. One is Q0 and one is Q1. So we have two bits, and how many like possible combinations of zeros and ones can be provided to these two bits? We know it can be 00, it can be 01, it can be 10 or 11. So there is a possibility of four separate states for this particular counter. So this count of 4 is referred to as the modulus of the counter, and that is why this counter is called a mod 4 counter. So basically mod 4 is representing that this particular counter is having 4 states. Now let us understand other things associated with this counter. Now, in the first flip-flop, you can observe that the J and K inputs are shorted together, and a bit 1 is provided at the input side. So when we short J and K and provide 1, you know what happens. As you can see from the truth table of the JK flip-flop, like when J and K both are 1, then the output gets toggled. That is, Qn plus 1 will become Qn bar. If it was 0, then after the clock pulse it will become 1. If it was 1, then after the clock pulse it would become 0. So this is the way in which this particular first flip-flop is working. Now let us see the second flip-flop, how the connections have been done. Here also J and K both are shorted, and after shorting, the like input is provided through the output of the first flip-flop. So this is connected from here, and J and K are both shorted in this case. So the output of the second flip-flop will be controlled by the output of the first flip-flop. It can be seen. And what other connections? We are taking Q0 and Q1 as the output from both the flip-flops to generate the counts. So let us see the working for this particular counter. Like we are assuming the initial state as 00. That means initially we are assuming that my Q0 is 0, and we are also assuming that our Q1 is 0. Now, as we can see from the symbol of the clock, it is edge triggered clock, which is negative edge triggered. So the symbol shows it is a negative edge triggered clock. So as soon as a negative edge of the clock signal is encountered, the flip-flop will be activated. Now let us see how this works. Initial state we are taking 00. Now let's see how this state changes to 01. The next state would become 01. We will see how it is becoming. Now see here 1 is coming to the first flip-flop for both J and K, and we know it will lead to toggling of the output. So we can see that the status of Q here or Q0 is 0 initially. So when the clock pulse will come, this 0 will change to what? The 0 will change to a 1. Now, at the same time, when the clock pulse is coming to the first flip-flop, it is also going to the second flip-flop. So initially we were having this Q naught value as 0. So J and K were both 0 initially. And we know when J and K are 0 as per the truth table, there is no change in the output when a clock signal is obtained. So it was Q1 was 0 and it will remain 0 even after the clock pulse is received. Because when the clock pulse is received, this J and K value was 0. So that is why it remains unchanged. So after the occurrence of the first clock pulse, we have Q1 equal to 0 and Q0 equal to 1. So writing in the order, we get Q1 Q0 is equal to 0 1. So this is how the state changes from 0 0 to 0 1. Similarly, we can study the state change from 0 1 to 1 0 in the next clock pulse, and then from 1 0 to 1 1, and finally from 1 1 it again goes back to 0 0, and the cycle continues. So the counter keeps on moving in these four states only, and that's why it is called the mod 4 synchronous counter. So try to understand the working of the next occurrence of the states, that is 101100. In case of any problem, you can post it in the comment section. Thank you so much for watching the video.